Alright, so here we go with the practice exam for electrochemistry. What is the oxidation number in sulfur and H2SO3? Well, hydrogen's always plus 1, there's 2 of them. Sulfur's got to be some oxidation number. Oxygen's always minus 2, and there's 3 of them, and the whole thing's got to add up to equal 0. So if this is negative 6, this is positive 2, that means we've got to have a positive 4 there for sulfur, so that would be C. Number 2, what is the oxidation number of chlorine in Cl2? Well, this is chlorine in its standard state, in its elemental state, and so it is 0, letter D right here. Remember, anything in its elemental state is always 0. What is the oxidation number of chromium in Cr2O7 minus, let's say minus 2 ion, hard to see, Cr2O7 minus 2. So oxygen would be minus 2, there's 7 of them, it adds up to negative 2. Chromium is some oxidation number times 2 plus negative 14 equals negative 2. So that means chromium's got to be, let's see if this is minus 14. I think it's got to be 6 then, right? Because that gives us positive 12, and that equals negative 2. So positive 6 then for chromium, which would be D, as in dirigible. All right, number 4 then, look at the reaction below, which species is oxidized. So you need to go through and assign oxidation numbers to see which one goes up in charge. Calcium is 0 on this side, iron is 0 on this side. You can see that there's nitrate on both sides, so don't bother breaking it up. Just say that it's negative 1 overall. And then iron right here has got to be positive 2, and calcium over here is positive 2. So calcium goes from 0 to positive 2. It goes up in charge and therefore is oxidized. So my up in charge oxidized species is calcium, letter A. In which reaction does the oxidation number of oxygen increase? So this is a tough one because you got to go through and you got to figure out which one has oxygen going up in charge, because they're saying oxidation number increases. So here oxygen is negative 2. And here oxygen is 0 because it's alone by itself, and so it went up in charge and therefore is the species that is oxidized. So letter E for that one. And you could go through and you could assign them for everything else, and you'd find out that it actually does not go up in charge like that. Number 6, in which species does sulfur have the highest oxidation number? So you have to go through and assign sulfur's oxidation number for each one. This one is 0. If hydrogen's plus 1 here times 2, that means sulfur's got to be negative 2. Sulfur here is going to be positive 4, because oxygen, of course, is negative 2, and there's 2 of them. In H2SO3, we just did that one over here, and we found out that sulfur was positive 4. And in this one, potassium's plus 1, there's 2 of them. Sulfur is something, oxygen's negative 2, and there's 4 of those, and it's got to add up to equal 0. So that means sulfur must be positive 6. And so there is where sulfur has the highest oxidation number, plus 6. All right, next page. What is meant by the term reducing agent? So you remember it's kind of like the opposite. So when a species is oxidized, that means that it is a reducing agent. It causes something to be reduced. And so the reducing agent is the substance that is oxidized in the chemical reaction, or the species that is oxidized in the reaction, letter D. Number 8, blank is the oxidizing agent. So if it's oxidizing agent, that means it is the thing that is reduced. And the reduced thing is the one that went down in charge, or went lower in charge. Reduction is the gain of electrons, if you want to think of it that way. And so we've got to go through and assign oxidation numbers, and then we've got to decide which thing went down in charge. And so here we've got negative 2, here we've got positive 1, oxygen's negative 2, nitrogen here is plus 5, this chromium's positive 3, this hydrogen's plus 1, this oxygen, let's see, it's NO2. I'm curious whether it's NO2 minus or that's a stray mark right there. I don't think it's going to matter. Minus 2 plus 5 right here, because that is minus 1 right there. well, this would be plus 3 then, I'm sorry, plus 3. So nitrogen would be positive 3, oxygen being minus 2 and has to add up to negative 1. And then oxygen right here would be minus 2, and then chromium here. We did Cr2O7 just a little while ago on one of these problems. I think it's plus 6. And so the species that's reduced or goes down in charges, chromium starts at plus 6, and it goes down to plus 3. So it goes from 6 to 3. So this is the species that is reduced and is therefore the oxidizing agent. And the thing that's oxidized would be nitrogen because it's at positive 3 and it goes to positive 5. That goes up in charge. Okay, number 9, what is the general definition of the term oxidation? Remember, oxidation is the loss of reduction electrons. Oxidation is loss, reduction is gain. So the loss of an electron in a chemical reaction is the general definition of oxidation. Number 9 is D. Number 10, the half reaction occurring at the cathode and the balanced reaction. So the cathode, remember, is the one that's reduced because it's red cat. So we're looking for the thing that goes down in charge or is reduced. So here, oxygen's minus 2, which means manganese has got to be plus 7. Hydrogen here is plus 1. This iron is 0. Over here, manganese is plus 2. Let's see. And so you can already see that manganese goes from 7 to 2, so it goes down in charge, and therefore it is reduced, and therefore it is the cathode. So it's our manganese going to manganese plus 2. And if we were going to write the half reaction for that, it'd be MnO4 minus goes to Mn plus 2. Keep the coefficients in there. And you're going to find that there's going to have to be some water in there, and there's going to have to be some hydrogen in here to balance that, because we've got awesome oxygens right here. So the reaction that you're going to be looking for, that is the half reaction, is going to include the MnO4 minus, but let's make sure that it's balanced, because we have 2 to pick from right here. And so if we put the 12 waters with this to balance the oxygens, that means we're going to need 8 hydrogens over here. I'm sorry, 24 hydrogens, right? 24 H pluses, that's what's in the equation. I don't know where I got 8. And so then we've got 12 and 12, and we've got 3 and 3. The charge balances with minus 3, going with the plus 24s right here, and then we've got positive 6 right here. We're going to need 6 electrons on this side to make it balance. And then we end up with this half reaction right here. But I think we can reduce things, because I think everything here is then divisible by a number. And so, because I think everything could go down some. And so I think we're going to end up with not using this number of electrons, but if we divide everything by 3 right here, then I think we end up with MnO4 minus plus 8 H pluses goes to Mn plus 2 plus, let's see, divided by 3 would be 4 H2Os. And then to balance that, I believe I've got plus 7 over here, and so I need 5 electrons here. And so A would be my best choice there in number 10. A whole bunch of balancing stuff that's going on there to make that happen. But the steps that you follow, of course, are just the balancing redox reaction steps. And then to get the half reaction, I just divided by 3 to get the simplest whole number ratio of everything in there. All right, I'm going to pause there, and we'll pick up with the next part of the the practice test in just a minute.